Hello, so today we're going to be going over another board that doesn't have any liquid damage on it, and we're just going to see what we can find and see if we can make it work again. So the first step here is to figure out what the symptoms are. So I'm just going to plug some of this stuff back in so we can just get an idea of what the symptoms are before I take everything out of the machine. So the first thing I'm going to want to do is plug the power in, see if I get a light, see what happens, and go from there. So I got my screen plugged in. I'm going to take my charger, I'm going to plug that in. Now, the first thing that I notice here is that when I plug it in, I get a green light in my charger and my fan spins. So half the battle is actually already won because it is turning on. However, it doesn't chime. Not only does it not chime, but, well, hopefully you can trust me there, is that there was nothing on the screen before I kicked the charger out of the plug. So it doesn't make a chime and there's nothing on the screen. Now at this point, a lot of people are going to think that the problem is that we have no image. There's an issue with the screen, there's an image with the graphics chip, they're going to start, heat gunning something, and this is where I want you to think a little bit. If we don't have a chime, our problem is not no image. Our problem is no post. It's not getting anywhere. So for example, if I were to take a USB mouse, if I were to take my gaming mouse here that I use for all of my extreme Dota matches that I win by last hitting so often, I would, if I plug in my gaming mouse, this gaming mouse comes for free with the purchase of any $40 NVR from China. You're going to notice something here. It never turns on. Our issue is not an issue of no picture. Rather, it's an issue of no brain. And let's go through how it is we would diagnose and solve that problem. Now, as many of you who build CPUs may be familiar, or build computers may be familiar with, there is a term called Vcore. This is the voltage that goes to the CPU so that it can do all of its basic tasks and all of its thinking. So we have to see if we have CPU Vcore. That's the first thing that we would check for. So this board is an 820-3209, and we're just going to check and see where it is we can measure CPU Vcore. And my computer is freezing, so it's freezing, so I gotta wait. Hello. Hello. Oh, there we go. Loaded. Beautiful. Just kick it. Yeah, I should do the same to this. What do you guys think? Just fucking kick it? Just bash it a little bit? Maybe I'll get my Vcore back? Motherfucker. God damn it. Piece of Okay, one more try. There we go. Bam! All right. Let's open ourselves a schematic and a board view. So, let's get started here. So where would I find CPU Vcore? CPU Vcore, where are you? Hello, CPU Vcore. Come here. Here we go, chipset Vcore rails. Let's check chipset Vcore rails. All right, so PP Vcore SO CPU. Let's try and find that. PP Vcore SO CPU. Please do not freeze while I'm capturing video. Please do not freeze while I'm capturing video. Please do not freeze while I'm capturing video. Okay, 0 volts. So, what are we going to do next? We're going to try to figure out where CPU Vcore comes from. Anyway, so let's find U7400. So this is a buck converter. And the way that the buck converter is going to work, very, very simple. This chip is going to cause the transistor over here to switch on and off. And just to give you an idea, I'm going to open up my notes. Let's find my... Here we go. I'm going to open up my notes. Buck. Here we go. There we go. So this is a buck converter. The whole idea is you take a higher voltage and you turn it into a lower voltage. So here's how you would make CPU Vcore. So we have let's say we have a controller chip here. This controller chip is going to control when these transistors open, and then the inductor and the capacitors are going to smooth it out. But you're probably confused at that because that's not really great an explanation. So we start out with a high voltage like 8. The buck converter is going to switch it on and off. 8, 0, 8, 0, 8, 0. And then when it's done, it gets averaged out to something like 0.8 volts. So this is what it looks like. So you got 8 volts at the top, spikes of 8 volts here, and then after the inductor, you have 0.8 volts over here, and over here, this is obviously ground, so you have nothing. And after that, it should be obvious what we're going to get over here. Doesn't it look very similar to this? In fact, it looks almost the exact same now, doesn't it? So we got this. See this? See this? Same shit. So let's check out what that buck converter trick looks like, that buck converter regulated by U7400, and with any luck, my capture hardware will not have frozen by then, but there's a really good chance that it'll have frozen by then because the machine that I record all these videos on is a complete pile of crap. One way to find out. So I'm just going to unplug everything that's plugged in here. We're going to look for U7400 on the board and see if we get anything that's interesting. So what are your bets? Do you think that this is going to be a BIOS issue? Do you think it's going to be a corrosion issue? Do you think it's going to be a burned component issue? Or do you think the board is going to fix itself like the trackpad one did in that last effing video? It's been happening too much lately. Alright, so let's take a look at what we have on the other side of the board. Oh! Oh! Gross! Oh! I feel a little better. But since I'm at the end of my Jägermeister bottle, I don't. Ew. I'm done? We've only had 2 or 3 episodes together. You're gone. Goodbye, friend. Oh well. Back to work. No use crying over used up alcohol. So, this is the CPU Vcore puck controller. And yeah, is it not obvious why this is not working? It's because nobody spilled anything on it, that's why. It's because nobody spilled anything on it, that's why. Okay. Let's get to work. We're going to turn on the fume extractor. And we're going to turn on the JBC. And we're going to... I don't think I will ever get a sponsor on these videos. I don't think any company in their right mind would sponsor anything that I do. Yeah. I was talking about that with the sales guy here. Because there is some company, you know, there are a lot of companies that have been sending me offers for all this type of stupid shit. By the way, if you want to know why it's not working, it's this one. And I'll explain why that's the one that's causing it later. Anyway, the capacitor being disgusting is disgusting, but that's not actually what's doing it. It's the resistor. So there are a lot of companies, though, that have been asking me to review shit, and some of it's interesting, some of it's just really stupid. Yeah, it's like, what would you think of some type of arrangement where you sell sponsorship slots, and receive commission? And he's like, I'm like, oh, what do you mean, And he's like, you know, you've kind of built this channel off of being an asshole, so I don't see how that works. And he wasn't being insulting about it. He was completely and utterly truthful. And it's the truth, and when I look back on it, yeah, I don't think I'd I don't think if I were an equipment company, I'm not gonna advertise with some dude that bashed a Baku station to pieces. No, that's not happening. So let's reconnect this nasty looking area. And we're gonna put a nice resistor on there. Put a nice little resistor on there, and I bet that most of our problems will be solved. So the first thing that I have to do is get myself a 90.9 kilo ohm resistor. All right, so the resistor that's burned is here for CPU IMVP underscore ton. TON stands for time on. This is going to set the time that the buck converter stays on. So let's check this out a little bit. So you see how we have spikes? Now we're going from 8 volts to 0.8 volts. Now, if we were going from 15 volts to 0.8 volts, we would have smaller spikes and more zero. In order to average out 8 volts to 0.8 volts, you need more spikes than you would if you were averaging out 15 volts to 0.8 volts. So the amount of time that the buck converter spends on, so see here, this is on, this is off. This is on, this is off. This is on, this is off. The amount of time that it spends on is going to be dependent on the voltage that's present at the top of the transistor, so the power that's actually being switched through. So PPVin SO CPU IMVP is going to this time on pin over here so that this chip can figure out how much time it should spend on. Because do keep in mind that this chip can be used in multiple designs. This can be used to turn 8 volts into 0.8 volts. It can be used to turn 12 volts into 0.8 volts. It can be used to turn 15 volts into 0.8 volts. It can be used to turn 20 volts into 0.8 volts, and so on and so forth. The entire point of this chip is to be versatile so that it can be used in multiple different designs. The ability of this chip to be used in multiple different designs is going to increase its value and also increase its versatility, which brings the company that made it, Maxim, greater returns. So the idea here is if we can simply, rather than just have it say this chip is designed to make 8 volts into whatever, if we design it to say this chip is designed to turn whatever into whatever, and we can have a pin there that's going to set what the source voltage is, then we're golden. We can use this in a MacBook Air, we can use this in a MacBook Pro, we can use this in an Alienware or a Dell or whatever the hell, and it'll work just fine. So CPU IMVP ton is going to be helpful because it allows us to use this in multiple different machines that use multiple different power lines. Now, if we cut that, if we never give it a source, if that via is broken, not the via, if the trace is broken, then it's going to see 0 volts at that pin, which means no switching. No time on. So we have to restore that, but we also have to find a 90.9 kilo ohm resistor because jackass here doesn't have a spool of them left, and the person who didn't spill anything is calling 3 times a day asking why it ain't done yet. So let's find a resistor. You would better not. You don't get to get caught here with a repair that takes longer than a day. Oh, you will have your heart and soul ripped out of you. It's right there. All right, let's get this started and on the road. All right, so this is going to go on sideways because, I mean, just look at what I'm working with here. Okay. Oh, again. This tip is ridiculously oversized for what I'm doing. Let's see if it came out looking the way that I want it to. Listen, I'm not going to say that it looks exactly the way that I'd like it to look, but you do the best with what you have, you know what I'm saying? All right, so now I just got to put that capacitor back in place. So let's find myself a nice, beautiful, equal value capacitor. And once I have that, I'll be off, set, and ready to go. And I'm sure after that there'll be no other issues. I'm sure that the liquid didn't go to anything else. I'm confident. See, this is what would make fixing other stuff a complete and utter nightmare. I mean, really, what makes me look smart and good and efficient at this is having a good donor pile. You know, if I want to test a theory, Hey, does this work or does this not work? All I have to do, the only thing I have to do is just walk over here and pick parts off. If I want to test a theory, testing a theory takes no time. Without a good spare parts bin, testing theories is a nightmare. Testing theories or seeing what resistance to ground is at certain points, and, you know, this all helps. Alright, so we put this here. Wait a second. The capacitor has a... That capacitor has a fucking chip in it. Get the fuck out. Hell no, I'm using that. Okay. Try number 2. That was bull. God bless surface tension. Alright, this thing still has to get ultrasonic because this is gross. We're just going to go over the board and check out some of the other sections of it, and let's see. What does our no liquid damage here look like? Alright, go over here. Boo. Bye. Shoot. Go away. No liquid. Let's go over the other side. Yeah, these diagnostic ports, let me show you what I think of this diagnostic port. So every single part of the machine, every single important signal often combines here. It's one of those JTAG ports, maybe for programming the SMC or programming the BIOS or something like that. I'd have to look at it again to see exactly what it's for. Here's the thing. Here's the way I see this, right? So this port, for me, it can be a liability if any of those pins short together, it gets corroded, right? It becomes a liability. However, it doesn't benefit me in any way, shape, or form. The only way that this benefits anybody is if Apple were to take this board back and want to repair it or want to test something, this would make Apple's life easier. Now, everybody here, raise your hand if you think that I should do work to make Apple's life easier. Raise your hand. Show of hands. Show of hands. Should I keep that port on? Should I solder a new one on the board? Yeah, I don't see any raised hands. Okay, so screw that. We're going to wick that and call it a day. Because I'm pretty sure at this point that this board will work just fine. So we're just going to wick that away. Yeah, corrosion on that can very easily wind up screwing up the board. Okay, now what we're going to do is we're going to plug this in. We're going to see if we have CPU Vcore, and if we have CPU Vcore, we will celebrate. I mean, I don't really know how to celebrate, you know. Would you really call an empty bottle a celebration? Ah, boy. So, it looks like I was able to get through, one video without the capture hardware screwing up. It's pretty interesting. I mean, granted, the entire fucking computer froze for quite a bit, but the capture hardware never screwed up. Something tells me that the capture hardware probably caused that to happen, but we'll see. We'll see. So first thing to do here is just plug this in and see if I have something I can work with. And if I don't, I'm going to go back and work on my impressions a little bit. See if I can get it. Okay, we're going to plug it in. I didn't plug the speaker in, so I won't know if I get a nice long dong. Hey, what do you know? The screen comes on. The screen comes on. I mean, it looks like shit from all that not water spilled in it, but Works! Come on, we get a question mark. I did leave the heatsink on and the fan, so I don't feel guilty about leaving it on until it gets to the question mark. Come on. Yeah, there we go. We got a nice question mark folder. And look, it's circled. The question mark folder is circled. Nice little puddle of no water. So that's it for today, and thank you for watching another episode of Component Level Board Repair. And as always, I hope you learned something.